Hi everyone. So today we're going to look at how to evaluate definite integrals with your graphing calculator. So far we have learned to evaluate them using the fundamental theorem of calculus, and that is what you'll need to do the majority of the time. But if you are allowed to use your graphing calculator in the future, this is how you can get the same answer much faster. So it depends on whether you take calculus again in the future, whether it be high school or in college. You may have a teacher or professor that wants everything done by hand, and in that case you'll just follow the last lesson that we covered. But if you have someone who lets you use a graphing calculator, then this is what you can do, and it goes really fast. You'll like this. This is going to be your favorite lesson of the year. Okay, so I'm going to take you over to the laptop where I have a program that will show you the graphing calculator. So I found that if I try to do a handheld calculator in these videos, you can't really see the screen that well, so I found that it's better to do this. So you will see that your calculator looks like this on the left side, and then the display is going to be over here, so hopefully you'll be able to see it well. Okay, so what you will do is graph the function that you're trying to find the integral for. So you're going to press y equals, that's in the upper left-hand corner, and you're going to put in whatever function is given to you. So look at number 1 on your paper. So that would be x cubed minus 3x squared minus 2x and plus 8. Okay, and then you will press graph, and you will see the graph appear on the screen, and then we are going to calculate the definite integral. Okay, so you're going to go to calculate, so you'll press second, and then calculate is on the top row, 4th button, and you'll see the screen that says calculate. Choose number 7. And in number 7, notice that that's the symbol for an integral. It's the elongated S. So press that one, number 7. So it brings you back to the graph screen. And at the very bottom down here, it asks you for the lower limit. So on the integral, our lower limit is 0. So you put 0 and then press enter. And then it says down here upper limit. So in this case, our upper limit is 2. So just press the number 2 and press enter. So you'll see 2 things happen on your screen. The answer to the question is at the very bottom. You'll see the elongated S, that's the integral of f of x dx equals 8. So 8 is the answer to our question. Now on the graph, what you will see is that there's an area between the curve and the x-axis that is shaded in. So if you recall, when you calculate a definite integral, that's what you're trying to find, is the area between that graph and the x-axis over a certain interval. So you'll notice that is going from 0 to 2 for that graph. Okay, so our answer for number 1 is simply 8. We could have gotten that answer the same way using the fundamental theorem of calculus, but that would have taken us a lot longer to get the answer. So this is a real quick way to get it. All right. So I'm just going to do a couple more examples. So go to y equals, and you can clear that one out. So for number 2, you're going to put in e to the x. So e to the x is with the natural log button. You're going to press second and e to the x. Put in the x for the exponent. And then it's plus x minus 5. Okay, so we have the equation. You are going to press graph. Here is the graph on the screen. And then you're going to calculate the definite integral. So you're going to go to second, calculate, choose number 7, that's the integral. It's going to say lower limit, so in this case it is -3. Press enter. And the upper limit is +3. Press enter. And then you'll see this on your screen. So at the very bottom, that is your answer. It says the integral of f of x dx is, and you'll want to round to the thousandths place unless you're told otherwise. So I would write down as my answer -9.964. Now look at the graph. You'll see that there are two sections in blue. That is everything on this graph between these numbers, -3 and 3, and to the x-axis. So you'll see that this piece over here is under the x-axis, so that's a negative amount. And then this piece over here is above the x-axis, so that's a positive amount. So what it does is it takes the net area, which means it adds the two together and gets the final answer, which is the -9.964. So the calculator has done everything for you. Okay, so one last one. I'm going to erase that one, number 3. So we're doing a trig function, the cosine of x, and we're going to graph it. There's the graph. And we're going to calculate the definite integral, which in this case choose number 7. And you have to put in the lower limit is, wait, I think I pressed the wrong thing. I'll have to go back. So a second, calculate number 7. Okay, there we go. So it has to say lower limit on the bottom. So you're going to put in pi over 2. So you have to use the pi symbol that is on your calculator. So it's over here on the far right where you normally press the exponent button, but you'll have to press second. So it's second pi, and then just put divided by 2. That's pi over 2. Press enter. And then the upper limit is 3 pi over 2. So put 3, and then the pi symbol divided by 2, and press enter. So at the very bottom, it gives you the answer, which is -2. And look at the graph. So notice that the entire interval is below the x-axis on the graph. So that means the amount is negative. So that's why you're getting an answer of -2. Okay, so that's really simple. And as long as you can use a graphing calculator, finding integrals can be that easy. But chances are good that you can't use it all the time in calculus. So anyway, you know both ways to do it. Number 1 is to use the fundamental theorem of calculus like we did in the last lesson. And number 2 is to use the graphing calculator. So I hope you enjoyed that, and I'll see you next time. Bye-bye.